Hello and welcome to the Ipv6 presentation series. I am Amit Vartak. In this video, I will be talking more about Ipv6 header structure. This is a standard format of Ipv6 header. If you just see at the header, most of the space is occupied with source address and destination address. Source address is 16 byte, destination address is again 16 byte. And the remaining 8 bytes are just occupied with general fields like version, traffic class, flow label, payload length, next header and hop limit. Let's see all these fields one by one. The first field in the Ipv6 header is version field. Version field has size of 4 bits and the value at version field will be 6. So all Ipv6 packets will be identified with the version field equal to 6. Second field in Ipv6 header is traffic class, which occupies 1 byte. This traffic class is to facilitate handling of real-time data. So the traffic class will be used by sending nodes as well as the in-between routers which forward the data, and with the help of traffic class one can differentiate between different classes for prioritization. This traffic class is very much similar to IPv4 TOS, that or type of service, but it is extended with 1 byte. Next field in Ipv6 header is flow label. It is of 20 bits. It distinguishes packets that require the same treatment to facilitate the handling of real-time data. So the sending node will put same value in this flow label in all the packets which require same kind of handling. So router will keep track of flow, and for the same flow they will process the packet in same way, or they will not do any extra processing for the same flow packets. So flow label and source address uniquely identify a flow. Nodes which don't process this flow label have to just copy this flow label and forward the packet. The fourth field in Ipv6 header is payload length. This is payload length which excludes the header length. This is 2 byte field. So maximum possible packet in IPv4 will be obviously 2 to power 16. In IPv4 this used to have the length of header as well. Extension headers are part of payload, of course. In IPv6 extension headers are present. So those extension headers will be calculated while calculating payload because it's a part of payload. Header is only 40 byte header, that's it. Next field in IPv6 header is next header, which is very much similar to protocol field in IPv4. It is of 1 byte. Now name changes to capture the extension headers along with the protocols. Now in IPv4 the name was protocols. The possible protocols are like IP or R and so on. But now along with possible protocols, some extension headers are also present. To capture those extension headers, the field name is next header, otherwise it is exactly similar to protocol. Next field in Ipv6 header is hop limit. It occupies 1 byte. This is very much similar to TTL or time to live in IPv4. TTL used to contain number of seconds for which the packet will be live in the network, but still most of the IPv6 routers just used to decrement the value while forwarding the packet. Now the name of the field itself has been changed to hop limits. It will exactly capture the behavior of the routers. So every router will decrement the value by 1 while forwarding. If hop limit is 1 and packet is received by any router will simply decrement the value to 0, and ICMP-v6 message hop limit exceeds in transit will be sent back. And here comes the last 2 fields of IP header, which occupies the most of the size of IP header. Source address, which is of 16 bytes. It is the IP address of the originator of the packet, and destination address, which is again 16 bytes, and it is the IP address of the intended recipient of the packet. It can be final destination, or if the router header is present, then the address of the next hop router. For example, I have captured a packet through Wireshark, and this is that packet. If you see the internet protocol header, IP header first 4 bytes are 0110, which is a version 6 bytes. So any packet with version equal to 6 will be classified as IPv6 packet, and it will be passed accordingly by your drivers. Next byte or next protocol header is traffic class, it's 1 byte, and currently traffic class is 0. Next is flow label. My originator of this packet has put the value as all zeros for the flow label, so current flow label is all zeros. Next is payload length. This packet is a ICMP neighbor solicitation packet, so the driver has calculated the payload length as some 32, so it has put the payload length equal to 32. Next header is it's the ICMP v6 packet, so it has put ICMP v6 or 0x3a in the next header field. Next is hop limit. The current hop limit is 255, so probably the packet has not reached any router and the hop limit has not been decremented any time for this packet by any router. By default value is 255. Next two headers are source address and destination address. So this is the source of the packet, this is the destination for which the packet is intended. After that, the next headers will come. In current packet, this is a neighbor solicitation packet, so the ICMP neighbor solicitation required all headers will be present in this packet. This is the way the extension headers are added to the IPv6 protocol packet. So this is IPv6 header. In IPv6 header, the next header value if equal to 6, it's a TCP packet, so TCP segment will follow. In IPv6 header, if next header value is 43, 43 is a routing extension header, so routing extension header will follow, and in the routing extension again next protocol value will be say 6, which is a TCP, so TCP segment will follow. If in IPv6 header next header is 43, which is a routing header, inside routing header if next header is AH, then this authentication header will follow. In authentication header, if next header is TCP, the TCP header will follow. So this is the way the extension headers are added to the IPv6 original packet. That's it for IPv6 header structure video. Thank you. Feel free to browse more IPv6 series videos on securitytube.net. Thank you.